Enterprise engineering and compliance data requires absolute precision, but standard artificial intelligence operates by making extremely educated guesses. Standard retrieval augmented generation, or RAG, turns your sentences into mathematical coordinates. When you ask a question, it searches for text that mathematically looks like your prompt, effectively playing a massive game of statistical word association. That breaks down when you ask a system to trace the exact downstream impact of a failed titanium bolt, or check if a new supplier meets GDPR Article 17. Standard models do not actually understand how a high-level requirement links to a CAD file. They retrieve words that frequently appear near each other, which leads to highly confident, entirely fabricated answers. You cannot run a manufacturing pipeline or a compliance audit on probabilities. High-stakes operations demand exact, deterministic proof. The deployment architecture of most commercial AI tools forces you to take your internal data and send it out to a public API. If you build aerospace components, manage financial portfolios, or handle medical records, exporting your proprietary designs to an external server is an immediate compliance violation. Even stripping names or converting text into vector embeddings falls short. External processing still exposes the mathematical shape of your most sensitive intellectual property to a third party. If an organization intends to use artificial intelligence on its proprietary intelligence, absolute physical control over the data is the minimum baseline to operate. kiLM addresses this by abandoning the single model method entirely. Instead, it relies on a dual-engine architecture. First is the neural pillar. Local language models and vision encoders ingest unstructured documents, read manuals, and parse diagrams. They act strictly as the system's eyes and ears. This diagram shows the system separating tasks. The symbolic pillar maps neural findings into strict logic systems, like a knowledge graph. At the bottom, neurosymbolic AI synthesis. Neural networks process unstructured inputs, while the output satisfies rigid, mathematical rules. By separating perception from logic, the platform removes the space where models invent information. If a relationship does not exist in the verified graph, the system cannot output it as fact. When you ask kiLM a complex operational question, the retrieval process looks entirely different from a standard vector search. A graph neural network traverses the knowledge graph, tracing verifiable paths from a supplier to an affected product. It consults an open policy agent along the edges. If a part lacks compliance certification, the engine instantly blocks the path. It evaluates the actual geometry of your enterprise data. This elevates the process from a basic semantic search to a provable algorithmic reasoning sequence. Because this engine wires directly into your compliance policies and engineering data, it must be contained within your own walls. kiLM is designed as a fully self-hosted platform. It operates securely with zero connection to the outside internet and enforces a strict air-gap lifecycle. Inside that environment, role-based access control is enforced all the way down to the individual vector. If a user is not authorized to see executive financial reports, the system physically filters those vectors out of their search space. You own the hardware, you own the weights, and you control row-level access. That is the strict standard required to deploy intelligence over protected assets. kiLM pulls directly from your CRM, ERP, and product lifecycle tools, ingesting everything from text to CAD files. It aligns these streams into a continuous thread, tracing an abstract engineering requirement straight through to a specific hardware test failure. Every time the platform generates an insight, it attaches exact document citations and provenance metadata. You can inspect the precise nodes and relationships it used to build the response. It stops treating artificial intelligence like a creative text generator and treats it like a measurable, governed engineering tool. For organizations managing proprietary designs and strict regulations, relying on public cloud statistical models is no longer viable. Intelligence that drives critical operations has to be provable at every step. It must be strictly governed by your internal policies, and it must never leave your physical control. Operating at the highest levels of industry requires